All right, so the last week we started learning how to solve systems of equations, and the strategies we used last week were by graphing them and by doing using substitution. And we would check our answers for substitution with the graphing. And so while I was going over that, I was like, well, why don't we just teach the graphing one since that one is the most visual and it seems to make the most sense, or it seems to be the easiest, especially since I could just, you know, go over here and check it on my graphing calculator. But the reason that we do teach these other strategies, as I was thinking about it more, is all the answers we've been getting so far is that they're pretty nice answers. We get whole number answers or integer answers, whether it's negative or positive, but we haven't gotten any decimals or weird fractions. Okay, so if you were graphing, it would be hard to, it would be kind of hard to guess if it wasn't exactly landing on one of these crisscross points. Like if, let's say the graphs intersected right here. Okay, that's kind of, we would have to do some guesswork on what the coordinates were for that point. So they don't always land on a nice point or a nice ordered pair like they have been. Okay, so that's just to give you a little reasoning as to why I'm teaching you these other strategies for systems of equations. And this week is going to be all about elimination. And I'm going to do my best to explain it, okay, because it's kind of a confusing concept at first. But once you get the hang of it, it's not too bad, and it's um, a pretty quick way to solve systems of equations. So if we're not going to solve this one by graphing, all right, I don't think I'd ever want to look at this one and think I want to do substitution, because it would be really hard to isolate a variable by itself and then substitute that value in, because we don't have any variables that don't have a number in front of it. And all of the numbers if we did solve, let's just say for x, on this one I'd have to subtract 5y over and then divide everything by 2, and 2 doesn't divide into 5 evenly, so that wouldn't be so nice. Same thing over here. If it's all for x, I'd have to add 5y over and divide everything by 3. 14 divided by 3 and 5 divided by 3 are not nice, and so on and so forth. So we're going to use the strategy called elimination. So I'll remind you that when we are working with equations, we always want to keep them balanced. So when we're always allowed to add or subtract or multiply or divide something to one side of an equation, but what you do to one side of an equation, you have to also do to the other. Okay? And one thing that I'm noticing right here is that this equation right here has a positive 5y, and this equation right here has a minus 5y. All right, so one thing we're going to learn that we can do is that we can combine this equation with this equation, and I'll show you how that works. So I'm going to just rewrite my 2x plus 5y equals negative 24. Okay, and then here I'm going to add, I'm just going to put a little plus sign in the parentheses over here, this equation down here to this one, because watch what's going to happen. So I'm going to add 3x, I'm going to add a minus 5y equals, all right, and notice how 3x minus 5y and 14 are equal. They're the exact same thing. 3x minus 5y is equivalent to 14. So the fact that I added 3x minus 5y to this side, that's the same thing as adding 14 to this side. Okay, I'll even put a little plus sign right here. So I didn't break any rules of equations right here. Adding 3x minus 5y to this side and adding 14 to this side are the same thing, because 3x minus 5y and 14 are the same thing. I'm going to have to continue this in a second video.